Our next pattern of change is called the single replacement reaction, and the tool is called the activity series. By using the activity series, we are able to predict products of a single replacement reaction. The activity series of metals lists the metals from the strongest of strong, most active, we see lithium, down to the weakest of weak, that being gold. In order for a single replacement reaction to occur, the element must be more active, higher than the element that's already involved in a compound for the reaction to occur. We talked about hydrogen. Even though hydrogen is a non-metal, it is indeed placed on the activity series of metals, knowing that it's always positioned first, carrying a positive charge. We made a further note that the elements between magnesium and lead are strong enough to displace hydrogen in an acid, but sodium above are strong enough not only to displace hydrogen in acids, but also that of water. We made mention that nonmetals can sometimes displace nonmetals that are in a compound, and we look at the activity series of nonmetals. The pattern of single replacement. When an element reacts with an ionic compound, it will form a new element and a new ionic compound if the element is strong enough to displace that that's involved in the compound. So we'll check the activity series as we proceed. Let's begin. Aluminum metal being dropped into phosphoric acid. Start with the left side of our equation. Elemental aluminum, written as Al, being dropped into, means it's reacting with, phosphoric acid. Remember the names of acids coming from the root word ic. Ic came from 8, the polyatomic ion phosphate. Acids, we know, always start with the hydrogen. Ic came from the polyatomic phosphate. We heard phosphoric acid, H3PO4. Elemental aluminum being dropped into phosphoric acid. Now notice, since we are looking at aluminum as a metal, oh, that didn't work. Aluminum as a metal, we compare it to the hydrogen that's written first. Is aluminum strong enough to displace the hydrogen that's in an acid? By strong enough, I mean, is it higher on the activity series? And so that's where we check. Aluminum indeed lies above hydrogen. Therefore, it will displace the hydrogen that's in an acid. This reaction will occur. Thinking in words, sometimes that's very helpful for students. Aluminum displaces hydrogen. The new element will be elemental hydrogen, and the new compound now begins with aluminum and ends with phosphate. Write that on your practice test with me. Aluminum metal dropped into phosphoric acid, in words, we can see produces elemental hydrogen and a compound of aluminum phosphate. Now we can turn these words into the formulas. Elemental hydrogen, of course, is diatomic, H2. And aluminum phosphate. Remember, when aluminum hooks, it hooks with a +3 charge. When it hooks to the polyatomic phosphate, it's a -3 charge. We get an electrically neutral compound, AlPO4. Then we go back to balance. 2 hydrogens on the right, 3 on the left. It's the old double the odd number trick. When we double the odd number, that gives me 6 H's, and I can repair that with 6 H's. However, that changed the phosphates, gave 2 AlPO4s to balance those, and backing up to repair the aluminum. 2 Als, 6 H's, and 2 groups of PO4. We now have a balanced equation. When fluorine gas is bubbled into a solution of magnesium iodide, elemental fluorine is written F2. Written into a solution of magnesium iodide, magnesium with its +2, iodide with its -1. Magnesium iodide, based on charge, Mgi2. Now notice, this is a nonmetal, so we compare it to the nonmetal that's in our compound. Is fluorine strong enough to displace iodine? Comparing the nonmetal activity series, we know that fluorine is the strongest of strong nonmetal. It can displace anyone beneath it. Of course, this reaction will occur. Fluorine is more active than iodine. Finish it in words. The new element that forms is elemental iodine, and the new compound now, metal first, magnesium fluoride. Elemental iodine is I2. Magnesium fluoride, based on charge, MgF2. And when we balance our equation, we notice the skeleton is indeed balanced. When lithium is dropped into water, remember our trick for water? I like to write water as HOH, hydrogen hydroxide. Oh, it's still H2O, just written in a way that helps us predict the products. I like water as HOH, not only for singles, but also for double displacements. We see the activity series says lithium is indeed strong enough not only to displace hydrogen that's in acids, but also the hydrogen that's in a water. This reaction will occur. Lithium being a metal, we compared it to the hydrogen, and indeed we said, yes, this will go. Now think about the words of our product. The new element is the elemental form of hydrogen, and the new compound is now called lithium hydroxide. Turn those words into formulas, and then we'll balance. Elemental hydrogen, H2. The compound of lithium hydroxide, LiOH. Now we'll work to balance. By separating water as HOH, notice how I have one hydrogen, but I have two over here. So I'm going to start by doubling my water. Two H's, two H's. But that also changed the hydroxides, the OH polyatomic. So I'll need to balance on the right side, two groups of OH. Two LIs, two LIs. 2:2:1:2 mole ratio. If copper metals dropped into zinc sulfate, elemental copper with a solution of zinc sulfate, that polyatomic ion is SO4 and it's a -2. Copper is a metal. We check the activity series of metals to see is it indeed strong enough to displace the zinc metal in a compound. We see copper lower on the activity series than the element that it's trying to displace. Copper cannot displace zinc. It is not active enough, not strong enough. This reaction will not proceed. If aluminum foil is dropped into solution of lead 2 phosphate, elemental aluminum, reacting with lead, Roman numerals telling me the charge, not how many. Its last name is phosphate, Pb3, PO4 taken twice, lead 2 phosphate. Is aluminum strong enough to displace lead on our activity series? Is aluminum more active than lead? Indeed it is. This reaction will proceed. Aluminum can kick out lead, so think of the products in words. The new element, the element of lead. The new compound, aluminum phosphate. Elemental lead is Pb. The compound aluminum phosphate, when I hook by charge, is electrically balanced with a 1-to-1 subscript ratio, AlPO4. Now that we have our skeleton, we balance. This compound begins our journey. 3 leads, 3 leads. 2 groups of the polyatomic phosphate, doubles the product, back up to repair the aluminum. 2, 1, 3, 2 balances that equation. The last objective is that of